Thanks for watching the screencast. We're going to review learning targets 12, 13, and 14 today. Okay, here is a problem from learning target 12 involving function graphs. So pause the video, take a look at this function graph on your handout, and then try to answer questions for parts A, B, and C. This is a graph of the calories you burn swimming after this number of hours. So here's the number of calories you've burned. Which one's the independent variable? Well, it's time. Time. Or maybe you'll put, the number of hours. Time is always the independent variable in a situation like this. Another clue that that's the independent variable is that it's what we graphed on the horizontal axis, the x-axis. The dependent variable is the number of calories burned. Did you know that you capitalize the C in calories? It's a unit named after a guy. So that's part A. Part B says approximately how many calories can be burned by swimming for 3 hours. 3 hours? Ask me to look at x equals 3. So x is 3 is right here, 3 hours. So about how many calories is that? Well, it's more than 1,200, I think, just a little bit. I'll say maybe that's about a quarter of the way between 1,200 and 1,600. Maybe I'll say about 1,300 calories. But here again, if you said, 1,250 or 1,400, I probably would not have any reason to doubt your answer. Just make sure that you can connect your reasoning because you found a point on the graph. If you can tell us what point you found on the graph, even better. Part C says if you want to burn 2,000 calories by swimming, about how many hours will you need to swim? So let me find 2,000 calories on the y-axis right here. And let's go take a look at which x value that would be. Right about there. So how many hours is that? Well, it's more than 4. It's less than 5. What do you say? Maybe about 4.5 hours? We'd take that answer. Or anything between 4 and 5. Or anything that's tied to this specific point on the graph. Okay, here are a couple of problems from learning target 13 about slope and rate of change. The fact that you'll need to know here, I hope you remember this, is that slope is the change in y over the change in x, or it's the rise over the run. So using that fact, that definition, pause the video and try to find these slopes. This linear function here on the left is given in a table. So to find change in y and change in x, I think it might help to use the table, like another column of the table, to find them. So what would I do to -4 to get 2? I think I'd add 6. Does that work for between 2 and 8? Yeah, 2 plus 6 is 8. Again, 8 plus 6 gives me 14. 14 plus 6 gives me 20. My change in x is 6. How much does y change by? Well, it looks like to get from -11 to -7, I need to add 4. And maybe again. -7 plus 4 is -3. -3 plus 4 is 1. 1 plus 4 is 5. My change in y is 4. So the slope is change in y, +4, over change in x, +6. Two positive numbers divide to become a positive number. Now, 4/6, I can divide both of those numbers by 2. That's 2 and that's 3. That would just be positive 2/3. There's the slope we need, 2/3. For this linear function given as a graph, I need to pick out a couple of points. Let's use this one here, -4, +4, and the y-intercept 0, 3. So here, I want to think about rise actually going down 1, and then I need to go to the right 4, and that's my rise over run. So my slope is -1 over +4. A negative number divided by a positive number is negative, and 1/4 doesn't reduce, it's just 1 over 4. The slope there is -1/4. Okay, here's one more problem that goes with learning target 13. Find the slope of the linear function that contains these 2 points. Pause the video and give it a shot. You know, I think the strategy that a lot of the students in Ms. Dillard's and Mr. Bowman's classes have used is to turn this into like a little table problem. Put those 2 ordered pairs, -7, 11, and -3, -1, into a little 2-row table, and then go back and use the definition that slope is change in y over change in x again. So to find the change in x, what would you do to get from -7 to -3? Well, you'd have to add 4. What would you do to get from 11 to -1? You'd have to count back. So negative, how far? It's 12. 11 minus 12 is -1. So the slope is change in y, -12, over change in x, +4. Now if you divide -12 by +4, you're going to get -3. 3 over 1, which is just 3. The slope of this function is -3. This first line equation is in what we call slope-intercept form, where the number at the end here, the number b, +2, is the y-intercept. It's where the line crosses the y-axis. The number multiplied by x, in this case -1/2, m, is the slope. So a fraction that means the same thing as -1/2 is -1 over +2. And if you think about that as rise over run, that tells you that to find other points on the line, you can start at the y-intercept and go down 1 and right 2. Down 1 and right 2. Down 1 and right 2. You can even go back and go up 1, left 2. Up 1 and left 2. Up 1 and left 2. So any of the points in that pattern are in the linear function. And there's a pretty good sketch of the line. Make sure you throw the arrows on there to indicate that the line goes on forever. You could solve this other problem one of 2 ways. One way to do it would be to find the x and the y-intercepts. To find the x-intercept, take the equation, copy it down, but then go and cross out the y term. Let y be 0. So what you get is the equation 3x equals -12, which you can solve for x by dividing both sides by 3, and get x equals -4. Right here. You can also find the y-intercept by writing the whole equation down. 3x minus 4y equals -12, and crossing out the x term. So when you do, be careful, don't lose this minus sign here. You've got -4y equals -12. And if you divide both sides of that equation by -4, well, -12 divided by -4 gives you y equals +3. So there's the y-intercept at 3. And now you've got a pattern for graphing. It looks like the pattern is that you'd go up 3 and right 4. So let's make more of those points, up 3 and right 4. And all 3 of these points are in the linear function. You know, you don't really need a third point to graph it. I feel like it just makes making the graph a little bit easier. Now another way to solve this same problem is to take the equation you're given and actually solve the equation itself for y. Put it in slope-intercept form. So if that's your approach, you're probably going to say, hey, this 3x here belongs on the other side as a -3x. So what I have is, and again, even with this method, don't lose this negative sign here. I've got -4y equals -3x minus 12. And then if I go and divide every term of this equation by -4, these cancel out. I get y equals -3 over -4 doesn't reduce other than that the negatives divide out. So you get +3/4 x plus 3, which is in slope-intercept form. It has a y-intercept of 3, and the slope is 3/4. So from this point, I can go up 3 and right 4 and plot another point. Or I can go down 3 and left 4. Does that line look familiar? It should, yeah. It's the same one we made the other method. You can use either method to graph that, and it doesn't matter which one you pick. You definitely don't need to do both. Okay, last 2 practice problems. Try to graph these 2 lines, and hit play when you think you've got it. This line y equals 2 is a horizontal line. It's the horizontal line that goes through the point y equals 2 on the y-axis. It's the line that every y value is 2. So it looks like this. The line x equals -5 is a vertical line. And it's the line through x equals -5. It's the line where every point on the graph has an x value of -5. It's all of these. So straight up and down like that. And again, they're still lines. Make sure that they go on forever with arrowheads both ways. Okay, it's time for you to take the mastery assessment now. Good luck. Thanks for watching.